I'm very happy to be here, and thanks for coming today. And thank you to the conference organizers for hosting me here. My name is Alissa, and I'm an engineering manager at Red Hat working on Kiali open source project. And the reason I'm here today is because I want to talk about service mesh, what service mesh is, why we might need it, and how Istio and Kiali open source projects can help us manage it. And before I dive into what service mesh is, I think it's important to understand the evolution of application architecture. How did we get to the point that there is a service mesh? And a good starting point for that is the monolith application. And by monolith, I mean a single unit of executable or a single process where all of our code is built, packaged, and run together as one piece. And a typical application could look something like this. We might have different modules or different components inside, some responsible for alerts or reports, data processing, stuff for UI, and so on. And different components might have different scaling needs, and also different components might need different timeline for fixing or upgrades and so on. So doing that in one piece is not very flexible. And in order to solve that and gain more flexibility, there was a move towards separating those components into independent units, where each unit is running in its own process, and it is communicating with other components in the application over the network compared to in-process communication in monolith. And this is what is called microservice architecture today. So we have microservices, they're independent, each is running in a separate process. They're language agnostic, meaning that everyone can be developed in a different technology. And then later on, this technology can be even replaced several times. And as long as the contract of API is kept with the other components, it is transparent for everyone. And they also can be scaled separately, and they can be upgraded at separate times and in separate frequency. And another move also supported the move from monolith to microservices, and that was a shift in the way we package and run software. And by that, I mean containerization. So containers are not a new technology, but Docker has made it really accessible to containerize our applications a few years ago. And that allows us to take our code, take our microservice, and build a container image from it, plan how do we do that, and then where do we store it in which registry. And with that came another ability, and that is spinning up instances from that container image to run multiple containers. And then comes the need to orchestrate all of those containers in large environments. And orchestrating containers mean running those containers on distributed multiple hosts, scaling them. Each might need different scaling, and some system needs to keep multiple replicas of each microservice up. And then there's a need to manage this entire container-based environment, seeing that we have enough hosts, there is enough resources, and so on. And for that, container orchestration platforms were created. Kubernetes is a very popular example. There are others like OKD or OpenShift, which is based on Kubernetes, and so on. Now, as you know, my talk today is not introduction to Kubernetes, and I'm going to keep that promise. But I want to spend just a little bit of time on some concepts which are very important for understanding service mesh and Istio concepts later on. So a pod is a group of one or more containers, and they share network and storage. And it is a very important ability for Istio and Service Mesh that a pod can hold one or more than one container, and we will see later on why. A deployment is an entity that is managing the pod definition and how many replicas would we like to have of that pod in runtime. A service is a very interesting entity. A Kubernetes service is an abstraction. It does not actually hold any applicative code of ours, but it is acting as an abstraction and as an access point to the pods that actually do hold applicative code for us, and it's also sometimes called a microservice. Now, in microservices, when they run Kubernetes, we might need to have something like that. So we have a Kubernetes service A, and the applicative code is in this pod, and then we have service B. In this case, it represents 3 replicas of our application. And then when they want to talk, this pod is approaching service B, and the request arrives to one of the replicas here. And with flexibility, we get many replicas. We might have a very highly complex environment. And with that highly complex environment, we might also get multiple points of failure. We might have microservices downtime, we might have network requests that failed, and we might have a combination of both. So we gain flexibility, but we also got some challenges that we have to solve. How do we manage the routing of requests between different services or between different versions of a service? How are we detecting those failures in downtime in time? How can we seamlessly upgrade services? And because all of the communication has moved now to be over the network, we need to make sure we are able to secure this communication. And this is where Service Mesh came to the rescue. So what is a service mesh, really? It is an infrastructure or a framework that is handling the communication part between microservices. And from technical aspect, it's often implemented as network proxies that are deployed alongside the microservices next to each replica. And Istio is an open source service mesh, and it's one of the most popular service meshes today, and actually it might be the most popular one today. So Istio started about 2 years ago. The word Istio is a Greek word and it means sailing, as many projects in the ecosystem of Kubernetes have Greek word names and they are coming from the maritime world. Kubernetes is a helmsman in Greek. Istio means sailing. Kiali is also a Greek word, and I will describe its meaning later on. And what Istio can provide us with is several very handy features, like load balancing between different replicas, which replica of our microservice is supposed to get the request. And it's supporting several different protocols. Traffic control, like routing. How do I know if I want to route it to here or there, or to which specific version of a microservice do I want to route it? Handling retries and timeouts in case of network requests that failed. How do I secure the communication? Can I switch it on easily? Access control, does this service have the permission to access this service? And the ability to collect and store and show metric and traces for all the traffic. And this is important terminology in Istio world, and it's also very much based on Kubernetes. So workloads, anything that's controlling on in the pods, for example, a deployment, and in some cases, the pods themselves can be also a workload if they were not created from a deployment. A service is a microservice or a Kubernetes service. And there are two labels, Kubernetes textual labels that are used by Istio. And those are label app and label version. And those are helping Istio to distinguish different versions of a microservice. For example, if I have two different versions of a microservice, the app label will hold the same value, while the version will be different. Now, before Istio, when we were deploying our microservice on Kubernetes, we might have something like this. For example, we have two pods here, and this is our actual code, the thing that we want to run. But in addition, we might have some additional code that we need here, like routing code. If this go here, if this call this, circuit breaking code that is guarding our service from being overloaded. And the problem with that is that any change in the routing or any change in circuit breaking configuration caused us to redeploy and upgrade our microservice. So even if we deployed for service B something new, we also needed to change service A. Istio has made these parts extendable. They were moved to external configuration. And that was done with the help of a sidecar proxy. So this proxy is a network proxy that is deployed in a container next to each instance inside the pod. The container name for that is Istio proxy. And the nice thing is that it's completely transparent to application code, to the container with the business logic. It's completely unaware whether it exists or it doesn't exist. And Voi is the open source proxy written in C++ that is currently used by Istio. So how does this magic happen? How did the sidecar just appear in our pod? We never specified anything in our deployment. One way, of course, to do it is manually, but that's not very efficient. So there is an automatic way to inject this to pod on creation. And in order to do that, we need to label the namespaces in Kubernetes to enable injection of sidecars per namespace. I put here an example how we can do it. And then in addition, a mutating admission webhook is installed by Istio that is listening to pod creation events, and it is injecting those two containers. One is the initial container and the proxy itself to the pod. And what the initial container does, it runs to completion. It means it's not always alive, and it is adding IP tables rules that help the proxy to perform the routing. And this is Istio architecture. So some main components are Mixer, Galley, Citadel, and Pilot. And Pilot is the component that's responsible for sending all this configuration to the different proxies. Mixer is a component that's performing policy checks and collects telemetry. The proxy are reporting metrics to the mixer. And a mixer is extendable. It has adapters. And for example, there is a Prometheus adapter. So all the proxy are sending metrics, and then they're stored in Prometheus. In addition, there's also Galley and Citadel. Galley is a very interesting component. It actually didn't exist when Istio was created. It was added later on. And it's responsible for certain configuration validations when configuration is sent to Istio. And Citadel is managing the certificates in case we are securing the communication. So now, when we started before Istio, this is the structure of a microservice in Kubernetes. And with Sidecar, now we gain this structure. We have our business logic code, nice and clean, and then next to it, there's the Envoy proxy. And this is how the communication is going to work now. So if this part is going to call this part, it will go through the sidecar to this sidecar and vice versa. Okay, and the business logic code is completely unaware where the code is going as long as it's arriving properly to its destination. Several protocols are supported for that, and the configuration that is routing is external, and it can be changed at any time in a dynamical way. And compared to Kubernetes, there is a slight change in the way that routing is done. Before Istio, what was happening is that the pod was calling a service was holding endpoints, the IP of the pods, and selecting some pod to receive the request. What is happening with Envoy and Istio is that the communication is completely bypassing the Kubernetes service and is doing an Envoy to Envoy communication. And now I want to go over some routing scenarios that are possible with Istio. So A/B testing is something that existed a while ago. It was not invented by Istio. And A/B testing means that we would like to test a version of our service compared to a newer version, and then we're going to run both in parallel and shift some traffic, and perform 50% of traffic to one and 50% of traffic to the second one, and then compare the results. Traffic shifting, canary deployment is a great example. I'm going to show it in a second, and mirroring traffic is a very handy feature for testing. So this is how A/B testing with Istio might look like. We have two versions of our microservice. And version 1 has 2 replicas, version 2 has only 1 replica. And now I'm going to send 50% of traffic to this one and 50% of traffic here. And this is called in Istio weighted routing. Why is it called weighted? Because we have 100% of traffic and we're putting weights or percentage to the portion of traffic that we want to send to each one of the microservices. And this is interesting because the proportion of the traffic is also completely independent of the number of replicas that I have here and here, which is something that's not done in Kubernetes. Now, of course, we have to be very careful. We have 1 replica. We cannot send too much traffic there because it's not going to handle it based on its capacity. But still, the flexibility is very nice here. This is another example of weighted routing, and that's canary deployment. Canary deployment is another way of testing a new version of a microservice. And in canary deployment, we're taking a very small portion of the traffic, we're starting small, and we're sending it to a newer version. And with time, when we see that everything is fine, we're going to increase the traffic there, scale it up until the previous version no longer receives any traffic. Matching routing is another way how can we manage traffic with Istio. And it is doing it not with percentage of traffic, but rather with conditions. For example, we can define condition like here. if I have a header with user Alissa, please send my request to version 1. All the other users are going to be routed to version 2. We can say that if a request is for HTTP method post, because version 2 does implement method post, but version 1 doesn't, please send all post requests to version 2. And there are several other conditionals which you can define. Mirroring traffic is an interesting feature because it allows us not to shift any part of the real traffic, and all the real traffic continues to go to the current version, but still test a new version. What happens is that the traffic is copied, all the real traffic is copied by Istio and sent to a new version. And Istio is also taking care of disregarding the response and not sending it back to the caller from the mirror traffic, so the caller will not receive everything twice. Having said that, if the requests are doing something that modifies your system, inserting records to database, for example, additional handling is needed because this is something that's not taken care of Istio because Istio doesn't know what is the request doing. So if you have something that's modifying your system, put in another database, put a mock, something like that, to make sure that it doesn't modify or corrupt your system. And now I want to talk a little bit about production. So while a lot of efforts are done to test microservices typically, unit tests, integration tests, quite often when we come to production, things gonna go wrong, right? And in order to take care of that, chaos engineering was invented. It was a term that was coined by Netflix a few years ago, and what it means is that we are testing the resilience of our system by intentionally causing breakdowns to different parts and seeing how the other parts of the system behave, and then we can improve our error handling, for example. And Istio is providing several features that are very handy for chaos engineering. For example, injecting delays, that is simulating either network latency or it can simulate an overloaded service, and error injection, which can simulate a service that got down. Now, what is really nice about this feature, it's a very good alternative for manually shutting down a service or scaling it to 0. And can we also define conditional errors? For example, I can define that the service will simulate that it's down towards only specific user, and the rest of the users will continue to work as usual. And this is, for example, how it might work. If I would like to test something with delay, I can inject delay to service B, and that means that whoever is calling service B will receive the response, the duration of how much it will take, plus 7 seconds of delay. And in case of error injection, I might say that user Alissa, we're going to get 500 error, and the rest of the users are going to work as usual. And I will show an example with Kiali, how it looks later on. Circuit breaking is a technique to set a connection pool to guard our servers from being overloaded, and Istio is allowing us to do that. For example, set a connection pool of 100 connections with no more than 10 requests to this service. It is also complementary with outlier detection. So Envoy proxy has the capability to classify instances or pods of a microservice as healthy or unhealthy based on several criteria. For example, if some instance returned 500 errors over 2 minutes, it can be classified as unhealthy. It will be ejected from the pool. It means it still is up, but it's not receiving traffic for the predefined time frame, and then it's returned to the pool. And after a while, it's evaluated whether it should be ejected again or not, and the length of how long it's ejected can be increased over time. Authorization and authentication are also possible with Istio, and authorization in this case is, can service A send this request to service B? So it's not about user or end user. The user of service B is service A. And those roles are visible across namespaces, and Citadel is the component that's creating certificates, and it can also monitor the accounts, service accounts for creation and create certificates for them, and then sending them to the proxies. Certificates are only kept in the memory, so they're not on the disk, and they are communicated to Envoy with a specific API. Other security features are defining gateway, which is controlling the ingress traffic coming into the mesh or egress traffic coming out of the mesh. We can block it or allow it. Mutual TLS is security where server and client are both authenticating each other. And again, in those cases, client and server are both microservices. And those certificates are handled by Citadel. And mutual TLS can be done on multiple levels. It can be switched on for the entire mesh, for a specific namespace, for a specific service, and so on. And all those configuration objects are made possible with several configurations. So virtual service is a very important one, and destination rule. And virtual service is the object we would like to take when we want to define the rules for how requests are going to a service within the service mesh, just the routing technique. So the load, the percentage of traffic, chaos engineering is defined with virtual service. A destination rule is configuring the policies, what will happen when the routing already occurred, and we want to make sure which replica is receiving the traffic. Mesh policy, gateway, service entry are also entities that are needed in Istio. Gateway is the one that is responsible for ingress and ingress traffic. Mesh policy is something through which we can define mutual TLS for the entire mesh. And service entry is an entity with which help we can add entities that are actually outside of the mesh to the mesh and see what is communicating with it. A good example for that would be a database that's installed on bare metal. It's not even running on Kubernetes. It's not part of the mesh, but we can still bring it to be part of the mesh with the help of service entry. All the objects in Istio are CRD, custom resource definitions, which is the way how to define custom objects in Kubernetes. And they're all done with a YAML format, which is also very standard in Kubernetes. So we gain flexibility, and now we know how to manage the communication between microservices. But now we got also a new set of challenges. For example, Istio doesn't have a user interface. How do I see things? How do I know if there's traffic now? How many versions exist for service A? Is the configuration that I defined even valid? Is security on for service C? I have no idea. And for that, Kiali was created. And Kiali is an open source service mesh observability focused on Istio. It was created in January last year, and it's also a Greek word, and it means a spyglass. Spyglass or a monocular through which the captain is looking where they're sailing for better observability. Some of Kiali features are visualizing mesh connections and traffic. There's a very nice topology that I'm going to show. Calculating service and application health through different metrics aggregations, configuring the routing through UI, so you don't need to always do it through YAML files in a manual way. There are certain validations of configuration that Istio Gali component is not doing, and Kiali is adding some configurations on top of that. There is a way to view metrics, traces, and logs all in one place. And what is the security configuration situation? Is it for all the mesh, part of the mesh, and so on? And a picture is worth 1,000 YAMLs. So I will show a little bit of a demo how Kiali looks. And my demos are based on the book info example. The book info example is a basic example that is shipped with Istio. And it's a polyglot little application. And what is interesting about it that some of the services have several different versions running. The reviews has 3, ratings has 2. And this is how it looks in Kiali topology. The graph, by the way, is based on data taken from Prometheus Matrix, and this is how it's dynamically built. So I would like to show 2 scenarios. One is focusing on routing, and the other one is focusing on chaos engineering. All right, so this is Kiali, and that's the overview page where it gains some basic information on cards focused on each namespace. And this is Kiali topology graph. Now I'm going to add some information on the percentage, how much traffic is flowing to every version of the microservice. This is the versioned up graph. There are different layouts, and I like this the best. So we can actually see how much traffic is flowing to each version of the microservice. And in review's case, it was default, so we had 30-something, 30-something, 30-something sent to each version. But now I want to change that. I'm not going to send any traffic to version 1, and I'm going to send 25% to version 2 and 75% to version 3. And I would like to have security on top of that. Istio Mutual means that we have security on, and the certificates are managed by Citadel. This action created 2 configuration objects, destination rule and a virtual service. And a destination rule is stating the versions of my microservice and the fact that security has to be on. And a virtual service is going to say how much traffic am I supposed to send to each version. In addition, for those who want to edit it here, there's a YAML editor as well built in. And now let's see what's happening here. In the background, there's the traffic generator that generates the traffic, but I'm going to add some more traffic here. So you can see gradually, you see that version 1 is receiving less and less traffic. And for version 2 and version 3, we have the locks that are indicated that the security is on. And at the moment, it became gray. V1 doesn't receive any traffic anymore. And for version 2 and 3, the numbers are starting to get closer to the configuration that I wanted. And with time, a few moments, it will get closer to that. And now let's see a little bit how configuration validation is working in Kiali. So for example, I made a typo and I'm trying to refer traffic to a version that doesn't exist. We're going to get an indication for that here. There are different indications, different levels of warnings, errors, and so on. They're all listed on Kiali website. And now I'm going to create another problem with my configuration, and I'm going to delete the destination rule, which means that the virtual service does no longer understand how to route things. And here's another wizard where I want to show how to create conditional routing or matching routing. So here, the routing can be done based on some criteria, header, method, authority, and so on, to create several expressions, several rules, and the traffic will be routed according to those rules. And here's another version of this graph. At the beginning, I showed the graph that was application graph with versions, and this is the plain service graph. It's Kubernetes services, the way they are connected. And it's also small and focused on the one that I was looking at. As you can see here, it's red because I played with configuration and I caused some issues. Okay, and the second scenario is for fault injection or case engineering. And for that, I switched on a nice feature for traffic animation. As you can see, the TCP for Mongo is looking different than the regular one. And here I'm adding a rule with YAML file. I'm adding a rule that's going to inject some errors that are facing those who are calling the ratings service. So also here, destination rule and virtual service were created. And now virtual service is looking a bit different. And the condition says something like this. Please return 500 error, 100% of the cases when I have a header with user Alissa when it's routed to V1. As you can see here, there's a badge on rating stating that there is configuration. And this is the book info application. I'm going to sign in here with some user, and the expected result is that business as usual, everything is working just fine because this user is not defined in my configuration for error injection. And now let's see what's happening to user Alissa. Rating service is unavailable. And this is made possible by 2 different things. One is the fact that I injected this rule to Istio. that's saying, okay, if you saw user Alissa, please return this error. The second one was proper error handling in the review service that called ratings that made sure it catches the error and displays a nice error here and not crash itself. Let's have a look how it influenced Kiali graph. Now we're seeing errors. So gradually it's turning yellow, now it's going to turn red, and now we're seeing distribution of 65% of traffic is good, and then 34% is red. And here we see distribution of 200 and 500, and we're also seeing this flag. So this flag is very important, the fault injection flag. It's returned by the proxy itself, and there are several different flags that the proxy supports, and it indicates why was this error returned. Because I could have got 500 error that's not caused by the rule that I injected. And it's an important distinction that helps us to understand and troubleshoot problems. And now we can also see the health. The health is calculated from the metrics. And if I take a different time period, it of course responds differently because with a larger data set, the errors are going to be considered in a smaller percentage. And the traffic for the ratings is showing how the services are experiencing that. So in this case, reviews is calling ratings, and we can see that the reviews is not successful in calling ratings for 100% of the cases because we injected the errors. Another nice way to troubleshoot such problems is with Jaeger tracing, and it's integrated into Kiali. So here in this example, I went to the calling service. It was reviews. And if I open any of the errors, I will see some more details of the trace. And I can see here also 500 error, response flag, and also HTTP, the ratings URL, which I was accessing. And this is a very nice way to just delete in one click all those configurations. And now I'm still logged in with user Alissa, but everything is working back to normal. And the graph has turned green back again. So there are a few more interesting Kiali features that I would like to mention. There is a very nice feature for finding stuff on the graph, finding and hiding. If you want to hide irrelevant things for you, you can hide. And in this example, I'm highlighting or finding all the connections where response time is larger than 130 milliseconds, and it's showing me two specific paths where it's happening. And for example, you can see here that version 2 has this problem, but version 1 and 3 do not have this problem. Viewing logs is a new capability that was added recently, and you can select any pod and any container, including the proxy itself, and see the logs. Runtime metric dashboards is a nice feature. Those are tailored dashboards to the runtime in the container, for example, for JVM, for Tomcat, for Quarkus, and so on. And more custom dashboards can be added. There's a documentation on Kiali website how to do it. Visualizing security is another important feature because we want to know where do we have security and do we even have security switched on. So I showed on the topology graph in one of the demos that I could switch on security for one service. And here I could switch it for the entire mesh, and we will have this lock visible at all times here at the masthead of Kiali. In addition, if we're switching it per namespace, or this is applied to all, we will see a lock on each namespace. And of course, if we switch it off for some namespace, we will see a clear indication for that this namespace does not have security on. So I really invite you to try out Kiali and Istio, connect on Twitter and see our demos. We are uploading a demo every 2 weeks for Kiali, what is new there. Please try it out, send contributions, questions, feature requests, bugs. And thank you very much.